Button? Yeah? Push the little red button. And you may want to put on a seatbelt. You know, you're much too tense. You're a young man. You need to relax. Learn to take some joy in your work. Do you like music? That's better.
The movie Men in Black from 1997 exhibits the two characters, Agent K and Agent J, driving on the ceiling of the Queens Midtown Tunnel due to the heavy flow of traffic. In order to prove the likelihood of this event, I had to conduct research as well as recollect physics information that I have learned throughout this school year. In the movie, the car is being propelled and pinned to the ceiling by rockets on the back of a car. Let's put Newton's third law to the test. Newton's third law states that for every action, there is an equal and opposite reaction. Forces always occur in pairs, and one body cannot exert a force on another without experiencing a force itself. The force exerted is the action, and the force experienced is the reaction. In this case, the rockets move forward by expelling gas backward. The rockets exert a large backward force on the gas in the combustion chamber, and the gas therefore exerts a large reaction force forward on the rocket. This reaction force is called thrust. Also, a car accelerates because the ground pushes forward on the wheels in reaction to the wheels pushing backward on the ground. The car in this scene is a 1987 Ford LTD Crown Victoria. These cars typically weigh 3,999 pounds or 1,820 kilograms and can reach a top speed of 399.9 meters per second. After watching the movie clip and researching some data, I determined that the tunnel is approximately 1,955 meters long. As I slowed down the video, it was easy to determine that the car travels through the tunnel for 60 seconds, but it only takes 18 seconds for the car to reach the ceiling. The average highway speed in a tunnel is 25 meters per second. In the movie, Agent K is played by Tommy Lee Jones, and I found that he weighs about 200 pounds, which is 90.7 kilograms. Agent J is played by Will Smith, and he weighs 181 pounds, or 82.1 kilograms. The first step in determining the likelihood of this occasion is to find the upward force needed. I added the mass of the car and the mass of each person in the car, and it came out to be 1,992.8 kilograms. Force equals mass times acceleration, so I multiplied the mass of the car and people, 1,992.8 kilograms, by 9.8 meters per second squared, the acceleration of an object, or the Newton per kilogram. The upward force needed came out to be 19,529.44 newtons. The next step, discover the proper acceleration of the car on the ceiling. To find the acceleration, I used kinematics, which is the motion of objects without reference to the forces that cause motion. I used the equation x equals VOT plus 1/2 AT squared. X represents the displacement or distance something travels, V is the initial velocity of an object, A is the acceleration, and T is the time it takes for an event to occur. The displacement in this case is the length of the tunnel, 1,955 meters. The initial velocity is 25 meters per second, the time it takes is 18 seconds, and the acceleration is what we need to figure out. After doing the math, I found the acceleration of the car to be 9.29 meters per second squared. The next action is to determine the actual force that the car has. The same equation is used, force equals mass times acceleration, so I multiplied 1,922.8 kilograms, car and people, with the acceleration we just found, 9.29 meters per second squared. This force came out to be 18,513.11 newtons. After this phase, I needed to conduct a trigonometry triangle to find the force in the diagonal direction, or the hypotenuse, and the angle of the rockets that were attached to the car. I used the Pythagorean theorem, a squared plus b squared equals c squared, to determine the hypotenuse was 26,909.74 newtons. I was able to figure out the angle in which the rockets were placed using trigonometry. The tangent of the angle theta is equal to the upward force divided by the sideways force. This angle came out to be 46.5 degrees. Due to the fact that rockets were placed on the back of the car, this event could be probable. It might be difficult to duplicate, but it could happen if the right rockets were used. After some research, I found a rocket that had enough thrust to lift a car. The thermal rocket RD-0410 can accomplish this event and is the same size as the rockets seen in the movie. It has a thrust-to-weight ratio of 1:8 and is able to thrust 35,300 newtons of force, more than enough to lift the car and pin it to the ceiling, allowing us to drive on it. Who would have thought this scene could actually be possible?